this is section 5.5, exponential functions. And what it's saying is if a is a positive real number, so a is, there we are. So a is right here. And that it has to be positive. It has to be a fraction, a decimal, or a whole number. But it cannot equal 1. Then the function is exponential. So for 1 through 7, make an XY chart with the values -2 through 2, and then sketch the graph. For the other problems except number 5, graph them on your calculator. And sketch the graphs for each number item on the same graph on your paper. Alright, so we are looking at this. It says graph y equals 2x by setting up a chart and graphing the function by hand. So what that's going to look like is we're going to make a table, an x and y table, and we're going to go -2, -1, 0, 1, and 2. Now, just a second. Okay, sorry, I had to find my calculator. So, if I take this, well, criminies. If I take this equation right here and put it into y equals, it would be 2 raised to the x power, and then I press second graph, I can see that I've got all my answers. So -2 is 1/4, or 0.25, -1.5, 0, 1, 1, 2, and 2, 4. That's what we want to write right here. So 1/4, 1/4, 1/2, 4.25.5, 1, 0 is 1, 1 is 2, and 2 is 4. Now to graph those, notice that all my y's are positive, so I'm going to draw my x-axis down here, and my y-axis here. So this is 0, -1, -2, 1, and 2. I'm going to try and make that a little straighter. Not much better. Alright, so I'm going to graph the ordered pair -2.25. Oh, let me give me some y's. I'm going to go 1. I'm going to go by, no, I'm going to go by ones. 2, 3, 4. Alright, so -2.25 is going to be about right there. -1.5 is going to be about right there. 0, 1, 1, 2, 2, 4. So what it looks like is it's going like this right here. Notice that the dots start out kind of close, and then they get really far apart. They start getting a little bit farther apart. Another thing that I would like for you to see is, let's look at these y values. Alright, we can see that the y values here are just getting bigger and bigger and bigger and bigger and bigger and bigger. But look at the y values on the other side. We're looking at the y, not the x's, the y values. Right here. Oops. Alright, so look at these y values. See? This number right here is still positive. All of the even farther away. See how they're still positive? It's unbelievable, but they're all still positive. So what this is saying is this line is going really close to y equals 0, but it's never ever going to touch. And then they're also asking us, is this a growth function or a decay function? Well, as the x gets bigger, what's happening to y? It gets bigger. So that's called a growth function. A growth function right there. All right, number 2. So this one says, graph those on the same graph. What do you notice about the base and the shape of the graph? Well, when they say base, what you need to remember is this is the base, this is the exponent. So 4 is the base, 10 is a base, and 1.5 is a base. So again, we're going to make our t-tables, x and y. And we're going to use -2, -1, 0, 1, and 2. And this one's going to be for y equals 4 to the x power. So y equals 4 to the x power. Second graph. No, second graph. Second graph. Hello. I don't think it's letting me touch it. Second, there it goes. Second graph. Well, good grief. I'll get it in a second. There it is. But let me get back down to my numbers that I need. Alright, so there's -2. And we can see it's 0.0625. 0.625. -1 is 0.25. 0 is 1. 1 is 4. And 2 is 16. So if we graph those, here's the x-axis, here's the y-axis. And I'm going to go by 5s right here. 5, 10, 15, 20, 25. My x's, -2, -1, 0, 1, 2. Alright, so -2, 0.625 is really close to 0. -1.25 is probably about right here. 0.1 is a little bit above that. 1.4 is about right here. 2.16 goes about right here. So we can see that one looks like this. That is y equals 4 to the x power. Alright, now let's do y to the 10th. So y equals 10, no, let me start over. X, y, -2, -1, 0, 1, and 2. So let's put it in the calculator. 10 to the x power. So 10 raised to the x power. Second graph. Alright, so -2 is 0.01. -1 is 0.1. 1 is 1. 0 is 1. 1 is 10. And 2 is 100. Alright, so -0.01 is a little below 0.06. So it's about right here. And then you've got -1.1, which is still below 0.25. We got 0, 1. And then we've got 110, which goes here. 100 is going to go way up here. So this is what y to the 10th power looks like. So what's happening? This 2 was 16. This 2 was way up here at 100. So as the base got bigger, it exponentially got bigger. Does that make sense to you? Because the 2, if we look at just the 2's, 2 16 and 2 100, see how much it raised up when the base raised? Okay, let's look at 1.5. What do you think is going to happen here? It's less than 4. Do you think it's going to be in this direction, in between them, or maybe below them? Let's look and see. I'm going to do my table right here. So let's use green. So x. Gosh, I can't draw. I can't write on this tablet. So x, y. And we get -2, -1, 0, 1, and 2. So if we go over here and we put it in the calculator, 1.5 raised to the x power, second graph. So -2 is 0.444. Well, here, 0.444. -1 is 0.666 repeating. 0 is 1. 1 is 1.5. And 2 is 2.25. So 0.4 is going to be above the 0.6. So it's still really low down here. This 5 is kind of out of sync. 0.6 is above these. Then you've got your 0, 1. And then you've got 1, 1.5, 2, 2.25. So this one is up. And then it's going in that direction. So what you should notice is that when the base increases, it exponentially it grows exponentially faster. When it's smaller, it's slower. Alright. So let me look and see what this is. Do these graphs ever cross the negative axis? No. And that's what that's what I was talking about when I told you to look at the zero values, or sorry, to look at the table, and we never get close to 0. So no, it never crosses the negative axis. Never. What generalizations can you make about these graphs? Well, what point do all the graphs pass through? Well, they all pass through 0, 1. What axis do the graphs never cross? Well, they never cross the y-axis. What is the domain? What x values are used? All the x values. So we say all real numbers, because all the x values are used. What is the range? Well, we said that it gets close to 0, but it never touches it. So y is going to be greater than 0. Can't equal 0, but it's greater than 0. Are the graphs growth or decay? All the graphs that we just did are growth. And we say the larger the base, the quicker the growth. And that's all for this video.